Alright guys, today we're going to talk about subtracting rational numbers. For the most part, it's going to work the same way as adding rational numbers, but there's a couple tricky things that I want to show you how to do that are going to be a little bit different than when you're just adding. So here we go. You're going to use exactly the same rules for positives and negatives as in the last section. So your rules were if the signs are the same, you add and keep the sign. If the signs are different, you're going to subtract and keep the sign of the bigger. So, and just to make it interesting, let's make this a negative 0.4. So I have negative 0.4 minus 1.87. So both of these are negatives, which means I'm going to add them and keep the sign. So here's my 0.4. Make sure that you line up the decimal. Then you're going to end up with 7, 12, 2. Bring down your decimal point, and that's pretty easy. And since both of these were negative, the answer will also be negative. So you add and keep the sign. Excuse me. In this case, you have to clean it up first. So these two negatives right here will make a positive. So I'm going to rewrite this using a plus there instead of two negatives. And then I can look at this and see that my signs are opposite. So when I have opposite signs, I have to subtract and keep the sign of the bigger number. My bigger number is positive, so I know my answer will be positive. So let's subtract. And I'm going to get 3. Borrow. 14 minus 8 will give me 6. 6 minus 4 will give me 2. And since my bigger number was positive, my answer is also positive. So that's just a review from last section. Now, the rules for subtracting fractions are mostly the same. So here, this is a very easy example. My first whole number is bigger than my second whole number, that means I can just go ahead and subtract these. But before I even do that, I want to make sure my denominators are the same, which they're not right now. I need a common denominator of 3 and 4, which pretty easy at this point. It's 12. So I'm going to write as 2 and something over 12 minus 1 and something else over 12. 3 times 4 will give me 12, so I need to do 2 times 4 on top, and that will give me 8. 4 times 3 is 12, which means 1 times 3 will give me 3 on top. Now let's look at this. My first whole number is bigger than my second whole number, my denominators are the same, and my first top is bigger than my second top. So this is a very basic problem. All I have to do for this is I need to subtract my whole numbers, which is 2 minus 1 is 1, and then subtract my top numbers, my numerators. 8 minus 3 is 5, and I keep my bottom the same. So there's the answer to this problem. Now, what if your first top number is smaller than your second top number and you do not have whole numbers? You just use your addition subtraction rules for that. So I don't have to mess with whole numbers or mixed numbers or anything like that. So my denominators are already the same. I made it kind of easy for you because I'm assuming you know how to find them by now. So I just want you to focus on adding and subtracting. So in this case, I can just go ahead and use my rules. I have different signs. This is positive, this is negative, which means I subtract and keep the sign of the bigger number. 3/4 is bigger than 1/4. My answer will be negative. And then 3 minus 1 is 2. I keep my bottom. Now, this can be reduced further. Both of these can be divided by 2. So 2 divided by 2 is 1, 4 divided by 2 is 2, and now here is your answer. Now, here's where it starts getting a little trickier. What if your first top, right here, is smaller than your second top, and you have whole numbers? Well, just borrow from the whole number. I need to make this bigger so I can subtract the 3 from it. So I'm going to borrow from the 2. The 2 will become a 1. And think about this 2 as 1 and 4 over 4, because 4 over 4 is 1. 1 plus 1 is 2. Plus 1/4. Okay? So this is the same as this. So 1 and 4 over 4 plus 1 over 4. This is going to be the same as 1 and 5 over 4. Okay, so I just basically went backwards, if I was going to turn this into a mixed number, if I was going to reduce it, I would just do 5 divided by 4, which would go in 1, so this would become a 2. That would have 1 over 4 left over. So it's kind of just a backward trick. And then minus 1 3/4. So now that I've rewrote this, now my first top is no longer smaller than my second top. I can go ahead and do this. 1 minus 1 will give me 0, so I'm not going to write down anything for the whole number. 5 minus 3 is 2, and then I'm going to keep the 4 on the bottom, and again, I can reduce this to 1/2. Here's where it gets even trickier. What if your first whole number is smaller than your second whole number? Then you have to turn them into improper fractions. That's absolutely important, because if you just try to do this using your addition and subtraction rules, you will end up with the wrong answer. So you have to turn these into improper fractions if your first whole number is smaller than your second whole number. 1 is smaller than 2, so you're in trouble. You got to turn them into improper fractions. To turn them into improper fractions, you have to multiply the bottom by the whole number and then add the top. So 4 times 1 is 4, plus 1 is 5, over, and you keep your bottom number the same, minus 2 times 4 is 8, plus 3 is 11. And now, as you can see, I just have fractions. I don't have any mixed numbers anymore. So I can just go ahead and use my rules for addition and subtraction. So this is positive, this is negative. Different signs, you subtract and keep the sign of the bigger number. 11/4 is more than 5/4, so my answer is going to be negative. And then 11 minus 5 is going to give me 6. I'm going to keep my bottom number the same. And then I can reduce this. So first of all, I can divide both the top and the bottom by 2, which will give me 3 over 2. Don't forget your negative. And then I can also divide 3 by 2, which will give me 1. So negative 1 and 1/2. This is my, if I did this long division way, this would be my answer, this would be my remainder, and this would be my divisor. Okay? And that's about it. I'm not going to make you try any problems on your own this time. You're going to try plenty of them tomorrow in class. Just make sure that you understand what I did here and why these little differences are so important. Feel free to play this over and over again, and bring your questions to class tomorrow.